Sometimes finding the indefinite integral for a function is sometimes a little tricky, and sometimes it takes a little bit of ingenuity, or sometimes it takes just seeing what to do. So again, for this example, you might want to pause the video, see if you can figure it out yourself, and then we'll see how you did. So again, give you a few seconds, pause the video, and then we'll see how you did. All right, supposing that you gave yourself an opportunity to try it. If we look at this, it says x to the fourth plus x squared on the inside, and you don't have anything on the outside. If you think of that as the u, there really isn't a proper du on the outside. Yeah, you could multiply by a bunch of variables, but remember that you cannot multiply by variables outside the integral symbol. You could only do that with constants. So what do we do? Well, what you can always do is you can always modify the form first. Do some simplifying. Do some rearranging. Do a little bit of changing, because maybe you can see where you're going to have your potential u and your du for integration. So for this one, if we see in the inside, we can actually factor an x squared from both. So we haven't done any integrating yet. We're just going to modify this to see if we can get our hands on something that we can integrate. All right, notice that we have the square root of x squared times x squared plus 1. And provided that the x is going to be positive, this is actually going to be equal to simply x times the square root of x squared plus 1 dx. Now if you look at it, does it look like you have a chance of determining the proper u and the du? On the inside, again, think of the inside as the possible u. U would equal to x squared plus 1. And then the du, the derivative of that, would be 2x dx. Does it look like we can get there with a simple adjustment by a constant? We have the x there, so yes. Let's go ahead and rewrite it, setting up to do the actual integration. So we have x squared plus 1 to the 1/2 power, and then we have our x dx. And all we have to do then is modify by a constant. So we get x squared plus 1. The derivative of that is 2x. We don't have the 2 there, but we can put the 2 there. Okay, there's the 2. And always remember to compensate with the reciprocal 1/2. Now we're ready to find the integral. So remember that this is going to be u and du. Remember, we're doing chain rule for derivatives in reverse. The 1/2 is still there. And then we have x squared plus 1. Power goes up by 1 to 3/2. Dividing by the 3/2 is like multiplying by 2/3. Technically, the plus c would appear here, but we're going to write that at the end. Simplifying this is going to be 1/3 x squared plus 1 to the 3/2 power plus c. Always remember that there's a possible constant. All right, students, this is an opportunity for you to receive a little bit of extra credit. I really want to see who's actually been watching the videos. So if you have been watching these videos and you've watched this one all the way to the end, you can earn a little bit of extra credit. What I'm going to have you do is answer this sports trivia question. You could look it up and just email the answer to me. What was the name of the Baltimore Colts player who kicked the winning field goal in Super Bowl V. Look up his name and email his name to me and say, I want extra credit, and give me his name and I'll give you extra credit points. We want to see who's actually been watching these videos. So again, the question is, name the Baltimore Colts player who kicked the winning field goal in Super Bowl V, and you will receive extra credit points toward your grade. And as an interesting point of interest, when he left the NFL, he went on and became an insurance agent right here in Thousand Oaks. So look that up for some extra credit.